Hello everyone, my name is Christian and today I'll be presenting my information retrieval project on explainable information retrieval or XIR in short. The goal of this talk is to explore how modern search system works, why they often behave like a black box, and how explainability can help us make them more interpretable and trustworthy. The black box problem. We all use search systems like Google, academic databases, and all. So after doing a search, we'll get a list of ranked result. But we don't know why the result is the rank of that result is first and second. Like it's not interpretable. But if we see the classic information retrieval algorithm like BM25 or TF-IDF, so they are understandable and based on that score, whatever, like it's a pure math. So based on that score, we can interpret why this result is ranked as the first and the second. But what happened in the modern information retrieval system, they follow complex neural network architecture. So they are opaque in nature. So we call them black box. So uh, it's very difficult or it's nearly impossible to interpret it like why they are rank a specific result in top or not. Even the developer who built the specific model are unable to specify the ranking system of that model. So this is the main black box problem. So to solve that, we can use XIR to some extent. So XIR is the solution to provide a human understandable explanation for the result of an IR system. It's about building system that can answer why question. Like if we got some result in the rank list, so with the help of XIR, we can explain like why we got the result in that rank list. So it will provide the result and the reason. So with the help of XIR, it will make the search more transparent, trustworthy, and accountable. It helps the user to build trust. So like it can take more precise decision. So why do we need the XIR? Like what is the actual need of XIR? So first for the trust and control, it will be for the user, like understanding why you got the result. Build trust and gives control over the refined query. Like if I am searching something and I know like if doing this search, I'll be getting a specific result. If I know, so I can refine my query to get a better result and all. And if I am a developer and I have developed some model, if I am not able to interpret it like why this is behaving like that, so it will be difficult for me to debug and all. With the help of this, it is easy for them to find the bias and do debugging. And for accountability also, like for high stake domains like legal and medical and finance. Like for finance, like if a model is predicting like the patient is a cancer patient, so here the accuracy are like at very high stake. So for that, it should be very accurate. So for if it should interpret it why it is giving a result, like if it is giving a positive or negative, so it should be interpretable. Now we'll see how XIR works. Method one will be intrinsic. So using model that are naturally easy to understand. For example, BM25 and TF-IDF. So after seeing the algorithm for these models, we can easily interpret it why they are ranking specific results. So in models like TF-IDF, like we can see like if the term is very rare, then it will be ranking that like it will be giving more priority to that. So they are easily interpretable. The final score is the direct sum of the score of each matching query. So the explanation would be the score calculation is only the explanation for that. So you can easily show a user like the document ranked high because the term retrieval appeared 5 times and contributed this particular number to the score. So this is easily interpretable, and we can also visualize with the heat maps. Now we'll see the example. Here, query is the cat and food. So my cat loves cat food. Here the cat is coming twice and the food is coming once. So in document one, uh, the cat is coming twice and the food is coming once. So the total score will be 3. Here we'll be giving uh, each word as a one score. In document B, the food is coming only once, so the score will be once. So for the user will be like if the query will be cat food, then we'll be ranking the document one and the top, and we can also explain like why we uh, kept the document at the first, because the total score will be 3 and the for document B the total score will be 1, as we can see here. The explanation, a document rank higher because it contains the both query terms and the term get appear multiple times. This is simple, clear, and fully transparent. Now we'll see how Exia works with the method 2, which is post hoc. So here what it is a explaining a complex model, opaque model after giving a result like why it gave that result. So this is a famous technique called line local interpretable model agnostic explanation. So with the help of this, we can interpret the complex model which are opaque in nature. So we'll see how line works. So it will take a retrieve document and it will create a small variation. It will remove some words from it and it will create a thousands of variation of it, and it will feed that variation to a model. So what it does is it will after feeding that variation, the model will see how the score changes for the particular variations. Like for a query, if we remove cat and we feed like cat loves food, first we remove cat and feed, it will there will be some changes. Then cat love food, we remove love, will feed cat food, then the score will changes. So with this we'll train a model. So it will intimidate the black box behavior just for one local example. So this will be a simple local model became our explanation. So we'll be seeing one example here. The original document is I cat love tasty food. The black box score will be 0.9, like it is highly relevant. But the question is, but why? Why it is relevant? Like we don't know. So for this, we'll be using the line methodology. First will be the original document is R cat love tasty food. So we'll be removing cat and we'll be calculating the score. So the score is 0.2. It's a big drop. Then I cat love will remove food. Then it is also a big drop. Like this we'll be doing for the several thousands of variation, and we'll be training our model based on these scores. So it will mimic the uh, output generation for the complex models. So the line trains a new simple models like a linear regression to find a pattern in these new scores. This simple model learns removing cat causes a huge score drop, removing food causes a huge drop. It assigns a important weights to each word to match those terms. Like cat will be, for example, 0.7 and food 0.6. But loves tasty, it is irrelevant. So it will provide less weight for them. So the black box model scored this document high because it contained the important word like cat and food. So now it is interpretable like why it is ranking it in the top of the result, because it is containing important words like cat and food. So with the help of this line method, we can interpret our result better. But still, the exia is not a solved problem. Like there's a core trade-off between exia, which is fidelity and interpretability. Fidelity is an example that is 100% accurate, but it may be as complex as the model, so which will be not as useful for the user. And high interpretability. It's a explanation which is very simple, easy to understand, but it might be oversimplified, which might not be accurate. So we should maintain the fidelity and interpretability. The goal is to find the right balance between these two for the right task and for the user. It may depends on the task to task and the user to user and their use cases. Those, so the summary will be the modern IA system are powerful, but black boxes. Like it cannot tell why they are giving ranking for this particular uh, results. Exia open these boxes to provide explanations. This This is essential for trust, debugging, and accountability. Method can be like intrinsic and post hocs. So this will be the my explanation for the topic of XIR. Thank you.